Alright, so our topic today is surface area of prisms and cylinders. Prisms, remember, are any two-dimensional figure that it's a top and a bottom, top and a base, and the lines are connected, the vertices are connected. A cylinder is the same idea except the top and the bottom are a circle. Now, when we talk about surface area of prisms and cylinders, it's helpful to remember the distinction between surface area and volume. So let's say, for sake of discussion, that we had a little tin of paint, a little can of paint here, and we wanted to talk about how much paint would fit inside the can. That would be volume. When we're talking about how much paint would it take to paint the outside of the can, that would be surface area. And surface area is what we're talking about today. Now, it's often helpful to, when we're talking about surface area, to talk about nets. A net is where you take a three-dimensional figure and flatten it out, essentially. So, for example, if this were a tin can, and I were to bring in a can opener and a pair of metal shears, I could cut the top and the bottom off, I'd have two circles, and then I could cut down the side of my can and flatten it out, and I would have a rectangle. So, generally speaking, also when we're talking about surface area, what we're talking about is just adding up the area, the two-dimensional area of each of the faces or surfaces of the figure. That's what surface area is about. So, for example, if we're taking this cylinder, now for prisms it's generally fairly easy. For cylinders it's a little harder for some people to conceptualize. But when we're talking about the surface area of a cylinder, remember that we're talking about two circles plus one rectangle. And if we call this the height and this the radius, then what are we talking about? Our two circles are pi r squared. So the surface area is going to equal 2 times pi r squared plus one rectangle, length times breadth. So the breadth here, or the height rather, is what we might call the breadth, so plus h. And what is the length? Well, the length is also the circumference of the circle, which is 2 pi r. 2 pi r. If you missed that last bit, remember that the length of this rectangle is just the distance around that circle. Now if I simplify this a little bit, I get 2 pi r squared plus 2 pi h r. And you can separate that out some other ways if you want, but that's good enough. Now the other thing we talk about when we talk about surface area is composite figures. Again, composite figures are made up of addition or subtraction of various pieces that we put together. So let's say, for example, we had a cylinder on the top of a prism of some kind. Now, the biggest problem that people often run into with the surface area of composite figures is forgetting that there are common surfaces that are not part of the surface area. So, for example, in this, we would realize that there is a circle there that is in common to both the cylinder and to the prism. So we wouldn't count that twice. We have to be careful about that, but we'll come back to that one in a second. Let's do a couple of examples. Let's assume that this rectangular prism right here had was 3 here, and 5 here, and 8 here, and we'll make those all in centimeters. Now remember, we're talking about surface area. So we're talking about two-dimensional measurements, so we're talking about centimeters squared in this case. If we were talking about volume, it would be cubed, but we're not talking about that today. So all we have to do is figure out all the sides. The surface area is going to equal, the top would be 3 times 5. But we have 2 of those because there's one down at the bottom as well. So 2 times 3 times 5. Then we'd have this side over here, which would be 3 times 8, and there are 2 sides the same. So 2 times 3 times 8, plus, and then we've got the front face and the back face, which would be 5 times 8, and there's 2 of those. So 2 times 5 times 8. We're running into our cylinder there. So 2 times 3 is 6, times 5 is 30, plus 2 times 3 is 6, times 8 is 48, plus 2 times 5 is 10, times 8 is 80. And when we add those together, we get 158 centimeters squared. And that's how we do that. Similarly, if we were looking at this cylinder here, we have 2 circles and a rectangle. Let's say for sake of discussion that our cylinder had a radius of 1.7 and it had a height of 5.3. We just fill in our formula, which we've already got written there. Surface area equals 2 times pi times the radius squared, 1.7 squared, plus 2 times pi times the height, which is 5.3, times, again, the radius, which we said was 1.7. And we can put that all into our calculator. There's not a whole lot of point with these involving pi of trying to figure them out in some tighter way. But if we put that all into our calculator and rounded it to 2 decimal places, we would come up with approximately 74.77 centimeters squared, if we were in centimeters. Okay? Composite figures, same idea. So what do we have here? Well, let's assume for sake of discussion we had a radius of 6 and a height here of 8, and that these sides were all the same. Didn't draw this three-dimensionally very well, but you get the idea. The sides are all the same. We'll make them 20, and we'll make our height 10. Now, remember, we don't want to count the common surface twice. There's a circle in the center here, which we don't want to count twice. So we could just count it once and then subtract it once or something like that. Or we can realize, think about it this way, we can realize that that circle right there can drop and fit in that place right there, and then we've still counted it all. So what do we need? We need the surfaces of this box, and we need the surface of the curved surface of the cylinder. So let's do that. Surface area is equal to, now the top and the bottom of the box are 20 times 20. So there's 2 of those, 2 times 20 squared, 20 times 20. There are 4 sides of my box that are the same, 4 times 10 times 20. This is 20 and this is 10, and those 4 sides are the same, so 4 times 10 times 20. Plus, I'm about to run out of room here, so I'm going to write it on the next line. I need the surface area of the curved surface. Now, if you'll remember from over here, my surface area of the curved surface is 2 times pi times the height times the radius. So we're going to go 2 times pi times the height, which is 8, times the radius, which is 6. And we can simplify this fairly easily this time. 20 squared is 400, times 2 is 800, plus 10 times 20 is 200, times 4 is another 800, plus 4 times 8 is 48, times 2 is 96, which would give me 96, and don't forget the pi. So if we wanted an exact measurement, we would have 1600 plus 96 pi centimeters squared. And if we plug that into our calculator, which we could have just done up here somewhere, we would get to 1 decimal place, but that's approximately 1901.6 centimeters squared. And that is surface area of prisms and cylinders.